So this is what we mean by operations science. John Shute, the lean guru, talks about balancing people and process in lean transformations. He also calls it social and technical aspects of the change. Now, if we lay out the people or the social change aspect on the horizontal and the process or the technical aspect on the vertical, we find the Taylorism or the scientific management of the olden days here, as you can see, where the people aspect is hardly there, and it obviously emphasizes the scientific aspect. Whereas many lean initiatives nowadays are low on the process, low on the technical side of it, but pretty much okay in terms of people and culture, with a lot of people emphasizing that. And what we want to bring back is bringing back science, bringing back rigor in the process and technical aspects of lean transformation without giving up and without de-emphasizing the people and the cultural, social aspects of change. So we have a causal framework here for improvement. These are the stakeholder requirements, and we have the financials, and we have the operational parameters that determine the performance of the operations, and finally the process variables within the operations that we can actually control. Okay. Now, these are the outcomes for customers. They deliver customer value, and this is the long-term shareholder value, and this is what our customers and shareholders want. And shareholders, want a higher return on the invested capital, and that can be achieved if we can move our levers properly, the process variables properly. And operations science really is about relating these levers to the outcomes that we want to achieve. It is relating the X's to the Y's and knowing the relationship between the X's and the Y's. For example, Little's law is a good relationship between a few of these variables. Every operations have throughput, flow time, and work in progress, and they can be related like this by Little's law. Another example is variability and utilization and their impact on flow time, and especially the delays within the flow time. And it can be given through this mathematical expression. And if you plot them in a graph, it'll look like this in a non-linear manner. If we understand really how this works, we will be able to massively reduce the delays. Also, operating curves, hardly anybody has known or heard of it, although this has been there in the lean body of knowledge for a very long time. This gives a relationship between throughput and work in progress. You could be here. This is your as-is situation with a high work in progress and very low throughput, and it can be moved here by taking some actions, and we know what actions need to be taken by how much, etc. Also, that means going into the lean zone. We also get another relationship of flow time versus work in progress, and both of them constitute the operating curves. There's another final one that I want to show you is the impact of inventory on the working capital, of course, and the speed of delivery, or our ability to deliver the goods, ship the goods to the customers, right? So this is known as inventory efficiency frontier. What is our fill rate on the x-axis, and what is the total inventory investment on the y-axis? And the blue line gives the best possible outcomes for a given organization. This can be determined for your company, and you could be, say, the current position of your company could be there on the red dot. And if we plot this blue one, we can figure out ways of moving down, like reducing inventory at the same fill rate, or improving the fill rate at the same investment level, or actually perhaps achieving a combination of both. And what this also means is that beyond the blue line is not possible, and this is another scientific tool. And so the operations science is really about linking the X's and the Y's using scientific principles, in the end getting that maximum return on the invested capital for the shareholders and the best outcomes for the customers.